So here we can look at a polynomial. It's x minus 8, x minus 2, x plus 7. These factors represent roots. Okay, so here I have the minus 7 root here. That's from this factor. I have my minus 2 or plus 2 root here from this factor. And from this factor here, I've got my plus 8 in here. Now, if I do a horizontal compression, so essentially I'm going to do this, y equals f of 2x, and so I replace the x's with 2x's. Okay, so every x got replaced with a 2x. What's going to happen to this graph? Well, this by the function notation, since I'm timesing by 2, I should divide by 2 or compress by 2. And notice what happens is that these zeros are going to get compressed by 2. So now we have 2x minus 8 equals 0. Well, that makes x equal to positive 4. Okay, so now it's equal to positive 4. We have the 2x minus 2. Okay, that 2x minus 2 now equals 0. So that makes x equal to positive 1. So it's there. So again, if that 2 gets compressed to 1, the 8 gets compressed to 4. And then my 0 at negative 7 gets compressed to 3.5. Okay, or sorry, negative 3.5, because 2x plus 7, the solution to that is going to be at negative 3.5. So you can see that the zeros all get compressed algebraically because we can see it in the factors. And that's when we substitute the 2x into this original function or do a horizontal compression by 2. So let's take a look at this and let's see what happens here. We've now combining some transformations. So we need to make sure we understand what part of the transformation is y, what part of the transformation is x. So inside and outside is important. Here I'm going to look at the outside first. So I have a minus, then a minus 1. Okay, so that means that I'm timesing by negative 1 first and then subtracting 1. Well, that's y, that's on the outside, so I just do it the way it's written. So my transformation for y, I'm going to write it here. So my change in y is going to be, I'm going to times by negative 1. So I'm going to get negative y old minus 1. And then I just apply this to every coordinate. So I get negative 0 minus 1, negative 1 minus 1, negative 2 minus 1, negative 3 minus 1, negative 4 minus 1. Okay, so those are all my y transformations. My x transformations are all in the reverse, so I just have to make sure I recognize what that is. Now I can see that's going to, if I remember everything's in the reverse, that's going to mean divide by 2. Okay, but I want to make sure that I have a process to do this. So my notation says I times by 2 to get back to my old x. So then my do part, what I'm actually going to do is the opposite of that, which means I can find that algebraically by solving for the other x. Okay, so this is the do part of it. I'm going to actually compress everything by 2 or divide by 2. So we get 1/2 here, 2, 4.5, 8. Okay, so all those coordinates then, these original coordinates here from this graph, now get translated into these coordinates. So this coordinate ends up being exactly right here. So there's where my vertex is. So drawing in my vertex, it's at 0, negative 1. There's my vertex. Okay, all the other points get compressed horizontally and flipped and shifted vertically. So 1/2, negative 2, right there. 2 over, negative 3 down. 4.5, negative 4 down. Okay, so 8, 5, 6, 7, 8, negative 5 down. So this has been horizontally compressed, okay, and then flipped and shifted down 1. Okay, so there's my new graph. And again, once we establish the coordinates, we don't square root anything after that. We're just applying the transformation showing up in the function notation. So here's another one. This graph is one that is probably not familiar to most people, but this is a new one. We want to start introducing new functions to you so that you get used to seeing new functions. This graph happens that if we let x get really, really big, the denominator is going to get pretty big and we're going to end up going to 0. So at negative infinity and positive infinity, it's going to go to 0. So it has a horizontal asymptote. Okay? So this graph has a horizontal asymptote at 0. And it's got these coordinates here, 0, 4. When I plug in 0, I get y equals 4. Square root 3 is about 1.7. And about 1.7, y is equal to 2. And negative 1.7, y is equal to 2. And it's going to be a graph that looks like this. And again, if you're not sure what these graphs look like, okay, you're probably not familiar with these. So it's good to just graph them on your graphing tool. Anytime you come up with a new function, you want to graph it on your graphing tool. But here you're usually going to be given the points to keep track of. The one piece that's not explicit on the table is this horizontal asymptote. So we have to make sure we bear that in mind when we do our transformation. So when we do the transformation here, again, we're going to start with now once we've established this graph in this table, what the function is largely irrelevant. We're going to do the transformations that are on the outside and inside of this function. So I'm going to identify the outside transformation. All of there is a minus 3. So my change in y is going to be just minus 3. So take my coordinates and subtract 3. So putting that through that expression, I'm going to get minus 1, 1, minus 1. Now, one thing that we have to be careful of is because this asymptote is not in the table, we just have to make sure that that asymptote also can be expressed with minus 3. Okay, so all the features get shifted down 3. So there's my asymptote. What's happening horizontally though? Horizontally, we have a horizontal compression of 2. Because it says times 2, and I know what my notation says is the exact opposite of what I actually need to do. And I'm going to show that by just solving for the other x. So I'm going to divide by 2 to get my new coordinates. So I take those x coordinates, I'm going to divide by 2 to get my new coordinates. So that's going to be root 3 over 2, 0, negative root 3 over 2. So that's about 0.86. So I'm going to draw these coordinates in. So at about 0.86, negative 1, there's one coordinate. 0, positive 1, there's another coordinate. Negative 0.86, negative 2 is right there. And the graph is basically going to be horizontally compressed. So it's going to have this kind of squeeze shape. Okay, and it's going to have the same asymptote, and it's been shifted down 3. So you can see that it's been squeezed horizontally and shifted down 3. And this is what we're seeing here. This is what we see in the notation as well. Okay, and being just one step, this is, especially for the x, it's not that hard to know the transformation. However, make sure that we understand that there is a process that we can do things backwards. That's solving.